All right, hi guys. This is a lesson 8.1 video. We are moving into something new from data. We're going to be working with 3D shapes. So we will eventually be able to identify shapes, identify parts of the shapes, and find surface area and volume. So just a little like warm up here, just because you're going to need to know these words anyway for when we identify shapes in this lesson. I would pause the video for a second here and see if you guys know the name for a shape that has 5 sides, 6 sides, and 8 sides. And if you could draw it as well, that would be great too. So pause that for a sec. All right, so hopefully you're back and you tried that out. A 5-sided shape, I'm going to type it up here and then drag it in, would be a pentagon. And that would look like this. 1, 2, 3, 4, 5 sides. A 6-sided shape is a hexagon, and that would look like that. 6 sides, 1, 2, 3, 4, 5, 6. And an 8-sided shape would be an octagon, like a stop sign. And that would look like that. 8 sides. Easy enough. All right, so let's talk about 3D figures. Gosh, I don't know why my nose is so runny. Sorry, guys. So a solid is just a 3D figure that encloses a space. Basically a 3D shape that you guys are thinking of, but it's closed. Okay, it's not open in any spot. So like at home, if you had a box that was open, like didn't have a top, then that's not a solid. A polyhedron is just a solid, a 3D shape whose faces are made up of 2D shapes. So that's most 3D shapes that you guys can envision, all right? So this would be both a solid and a polyhedron down here. It's drawn with these dashed lines because if this was a true non-transparent, meaning like I couldn't see through its shape, I wouldn't actually be able to see those parts of the solid, okay? But it kind of lets us then see all the sides without being able to turn it because it's hard to like look at 3D shapes in 2D. So I would encourage you guys, if you have like a box, like a cereal box or a tissue box or something like that at home, pause the video and go grab that. And that would be helpful to just kind of have to look at while we talk about 3D shapes, okay? So pause if you need to, and then play when you get back. We're going to talk about 3 vocab words in relation to solids. They're color coded here, so you can see in red, this is pointing to this red shaded in part here. The blue is this line right here. The green is that dot right there. So the red word first, that is a face, okay? A face is that flat surface of a polyhedron. Basically, it's one of the 2D shapes making up your 3D shape. So this is a rectangular face of this entire solid would be called a rectangular prism, and we'll talk more about that in a few minutes. The blue here, actually, you know what, before we go to the blue, let's talk about faces a little bit more here. So there are lots of faces on this shape here. If I highlight in some more, like if I went right here and colored that in, that would also be a face, right? I could color in over here, that would be a face. How many total faces do you think are on this rectangular prism? And again, this is where it might be helpful to be holding a rectangular prism in your hand, some kind of box. So see if you can figure that out. Hopefully you came up with that there are 6 faces on this rectangular prism, okay? There is top and bottom. So this one up here, this one that I'm tracing out with my cursor down here, is what we call opposite of that face. It's perfectly parallel to it, like they would never touch if they were to keep going. And that means that they're congruent, they're the same size. There's also, I'm going to try to color code this here. Make this one pink. So this one on the side here, that would be another face. Let's call that our right side. Well then, this one over here on the left that I'm going to trace with my cursor would be the one that's the same size as that. That's the one that's parallel to it. So we've got 4 so far, top and bottom, right and left. And then we also have front, and the one opposite from it, the one in the back. So there are 6 faces there. Okay, I'm going to get rid of the highlighting just so we can see more clearly. All right, next, the blue word is an edge. An edge is a line segment where two faces intersect. So that's like literally just like these lines that you see on your 3D shapes, okay? So two faces intersect there. The one we called the front and the one we called the bottom are intersecting. So this one and this face intersect right here to make this edge. So see if you can count up how many edges does this shape have. You're counting those all up. What did you guys think? Maybe we should trace over it together. So we've got 1, 2, 3, 4, 5, 6, 7, 8. Wait, that was bad. 9, 10, 11, and 12. Okay, so there are, and then I didn't trace over this one. It kind of looks like we missed it, but it's just a different color blue. Okay, there are 12 edges. Whoops, not 13. 12. And then let's kind of clear that out of the way so that we can see again. And then that last green word is referring to this spot. There's not really dots on the shape, right? But this spot where this edge, and this edge meet. So it says a blank is a point where 3 or more edges intersect. I'll give you a hint on this one. We would probably call that a corner, right, of the shape. What's the math word for the corner of a shape? But you know it. It starts with a V. It's a vertex, okay? Vertex is kind of a tricky word because if we have one, we call it a vertex, but if we have many, we call it vertices. So it's one of those words that kind of changes when it's plural. How many vertices do you think this rectangular prism has? Again, you can pause and take a second to figure that out. So hopefully you guys came up with 1, 2, 3, 4, 5, 6, 7, 8. Okay, that shape has 8 vertices. That's what it looks like when you write it plural. Okay, so part of your homework today is literally just be looking at shapes and identifying how many of each of these vocab words. Okay, how many faces does that solid have? How many edges? How many vertices? A good thing to look at, and this was posted on Google Classroom and is also included in the packet if you got a paper version of the packet. Let's see if I can switch. There we go here. This website, the NCTM one, is a good one to be able to interact with. You can move that shape around. And you can, if you change here, you can color in faces and edges and vertices to kind of figure things out. The only shape that like we're really going to learn about that they have on here is a cube. The tetrahedron is actually a triangular prism, so you could look at that one as well because we will talk about triangular prisms as well. But all these other shapes, while super cool looking, are not ones that we will actually talk about in 6th grade math. That's an octahedron. We've got a dodecahedron. You might have like dice like this from like games at home. I know I do. And this also looks a lot like dice that maybe you've had before. You can create your own if you want to get real fun and fancy. But we're just going to look at the cube for now. Just kind of want to show you guys. So if I were to click this, click color, and then once I take my cursor, then I can color in a face, okay? And then if I want to rotate my shape, I could color in the one across from it the same way because I know that one's identical to it, right? And then like maybe I'll take this one to be pink and then I'll rotate and go, okay, well, if that one's pink, that means this one over here is pink. And then I'll make one of them green. So this one's green, which means this other one would be green. So now when I rotate it around, I can see all my 6 different faces. To do edges and vertices, you can do that as well. Maybe I'll do like the darker blue for edges. So if I just try to like hover on the line, then you can see it changes. And if you guys notice over here, it's counting it up for me. So it counted up that there were 6 faces, and now I know I've got everything colored in. So edges, as I click on more of these lines, it's keeping count for me. It did a vertice on that one instead. I must have clicked right on the corner. And you guys kind of get the idea, right? So as we click through here, you can see it'll eventually add up to 12 for the edges once I get them all clicked on. There we go. That should be all 12. And then I could do the same thing with the vertices. I could click where those 3 edges meet, to figure out how many vertices the shape has. Now the cool thing, once I finish this off here, is that you can also, if you look up here, right now we're looking at it as a solid, okay, 3D shape, but you can also look at it as a net. And a net is basically if I take a 3D shape and I were able to cut it up and lay it flat. So it's a 2D drawing of a 3D shape. And that can be really helpful when we get to surface area. So now you can see that's what it looks like if I were to cut open that shape. So that makes it very clear to me that there are 6 faces. And now I can see, oh, yep, these ones would be across from each other, these ones and these ones. It'd be easy to count up faces for sure and to then figure out surface area. So just kind of cool, and you can rotate it around. You can zoom in and out. So just a fun tool to play with. And again, like I said, this one that they call tetrahedron is technically just a triangular prism. So if we have them fold that back up into a solid, you can see that's just a triangular, sorry, did I say prism? Triangular pyramid. Big difference, okay? This is a pyramid, not a prism. We'll talk more about that right now. So let's go back to the lesson. There are 2 main shapes we're going to talk about. We name polyhedra by their base, and prisms and pyramids have different types of bases, and that's basically how you're going to be able to tell the difference between, is this a prism that I'm looking at or is this a pyramid that I'm looking at? So prisms, let's start with that. What we just looked at on the last page, this is a prism. What we just looked at on that website, the cube, is a prism, okay? So prism is a polyhedron, which remember is just a fancy word for a 3D shape, basically, that has 2 parallel and identical bases. This is the important part here, okay? 2 parallel and identical bases. Parallel, think like in 2D shapes. You guys know that parallel means that they're never going to intersect, and they're always the same distance apart, okay? Same thing in 3D shapes. It just means that it's 2 parallel entire shapes that are the same distance apart and never going to intersect. They also have to be identical, okay? Same size, same shape. So when you look at a prism, if I look back here, if we call this my base, it has another one parallel and identical to it, okay? So this would be called a rectangular prism because we name prisms by the shape of their base. This one's called a triangular prism because even though it's not sitting on its bottom, sometimes base kids think means bottom, but it doesn't have to be sitting on its bottom. But it has these 2 identical and parallel triangles, okay? So that's why it's called a triangular prism. So it's got 2 of those triangular bases. And then if you look, what are the other faces on this shape? Can you tell? We call them lateral faces, the ones that like aren't the bases. Lateral means side. Hopefully you can see that those are all rectangles, right? And we'll talk more about a triangular prism on the next page here. So that's your one type of shape. So rectangular prisms are prisms. These guys. Cubes are prisms. There's triangular prisms. You can have octagonal prisms, hexagonal prisms, pentagonal prisms. It just means that those would have a pentagon for a base or a hexagon for a base or an octagon for a base. I can show you some more in a minute. The other main type of shape we're going to look at are pyramids. So prisms and pyramids. That's what we need to worry about for chapter 8, okay? If you just even look at these 2, hopefully you can see some differences. Okay? A pyramid is a polyhedron, fancy word for 3D shape, that has 1 base, 1. So prisms have 2 bases, 2 parallel and identical bases. A pyramid has 1 base. Look, here's its base down here. Is there another base across from it that's the same shape and parallel to it? No. It comes up to a point like that, right? It comes up to a vertex up here. So pyramids have 1 base and then a bunch of lateral faces that are always, 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 always in pyramids going to be triangles, okay? We name pyramids for their bases as well. So a pyramid could have a rectangle as a base. It could have a triangle as a base. It could have a pentagon, a hexagon, an octagon. But the key thing is that pyramids have all triangles as their lateral faces and then 1 singular base. That could be any 3D shape, or sorry, any 2D shape. Prisms have 2 bases. Again, could be any 2D shape, but they have that for bases and then basically parallelograms, 4-sided shapes, as all their lateral faces, okay? Kids tend to get triangular prisms and triangular pyramids mixed up a lot because they both involve triangles, so it gets a little confusing, but they do look different if you think about it. Let's actually go to the other website that I linked for you guys. So it takes you to this page, I believe, to default. But then if you look down here, see where I'm moving my cursor, it says Explore Prisms. This, if you scroll, is going to let you kind of play around with some stuff, okay? So it'll give you the net, which is nice. It's moving it around. If you click on it, it'll stop, and then you can kind of control how you want to look at it. So this would be another example of a triangular prism. It's got, so I'll try to kind of move it so it's on its base there. Okay, so it's got 1, 2 triangles, and then going along the sides, 1, 2, 3 rectangles, right? So 2 triangles that are parallel and identical, opposite from each other, and then 3 rectangles. So 2 parallel and identical bases. It gives you all the data down here, number of faces, number of vertices, number of edges. If you like click, it'll highlight. For the faces, it just like makes them all the same colors. I'm not sure it's super helpful. But for like vertices, it puts the little dots just like we looked at, edges, it outlines those for you. If you click play over here on the net, it'll show you it folding it up and then unfolding it again. So you can see there that, oh yeah, a triangular prism is made up of those 2 triangles and those 3 rectangles, okay? Rectangular prism, same thing. Kind of rotates it around for you. We already figured out that it has 8 vertices and 12 edges. Again, here it'll show you the net. Looks a lot like that cube net, except for that in a rectangular prism, some or all of the faces are rectangles. So then that obviously gives it a different shape. These 2 rectangles I know are congruent. These 2 are congruent. And these 2 are congruent. Remember, that just means same size. So if I click play, it shows it folding it up and unfolding it again. And then, like I said, there can be other types of prisms. So I said pentagonal, just pentagon, okay, 5-sided shape. So I can have a prism where there's 2 pentagons, parallel and identical to each other. That means there would be 5 rectangles going along the sides, right? So I'll let it play there again. That's going fast. Let's slow that down. There we go. Good golly. So there's your pentagonal prism net. You can see there's the 2 pentagons, and then 1, 2, 3, 4, 5 rectangles going along the side, and you can watch that get folded up. So again, I'll let you guys play with this, but this would maybe help you understand what prisms looks like. An octagonal prism would just be a prism that has 2 octagons that are parallel and congruent to each other. So those are your bases. And then 8 rectangles going along the side. Now, stop. If you look down at the bottom here, I can then go ahead to pyramids. And they have the same thing for pyramids. And this would hopefully help you guys see the difference between triangular pyramids and triangular prisms. So look at the net of a triangular pyramid. All triangles, okay? It's got a triangle for a base and triangles for faces, for the lateral faces. A triangular prism has triangles for the bases and rectangles for the faces. So different. If I play and have this fold together, I can see that is much different looking than a triangular prism. Okay. Again, pyramids, you can have lots of different types. They're just named by their base. So this one has a triangular base. A rectangular pyramid has a rectangle, or this, is a square, but a square is a type of rectangle for a base. So you can see that fold together. We will mainly focus on, when we start to figure out surface area, triangular pyramids and rectangular pyramids. But just for like identifying faces and vertices and stuff, you guys could have any type of prism or pyramid. So you might have a base that's, like a pentagon, like this. Or a hexagon. And then that just folds together. Okay, so let's head back to the notes here so you guys can play along with that. Some of your homework problems will be just like to name the figure. What I tell kids when you're naming a figure is think about it basically has a first name and a last name, just like you. I'm Erin Gillespie. You're whoever. Should I shout out a name here? I won't, just in case. So first name, last name. The first name is, you name prisms and pyramids by the shape of their base. okay? And then the last name is either going to be pyramid or prism. So I'd probably figure out last name first. Is this a pyramid or is this a prism? Now remember, pyramids only have one base and everything else is triangles. Prisms have two parallel and identical bases, and those could be any different shape. Just they have to have two bases. They have to have two shapes across from each other that are parallel and identical. So, what do we think this is? Looks to me like it's a prism, right? A pyramid would have one base and then all these other shapes would be coming up to a vertex up here, and they're not. I see like two vertices up here. So this must be a prism. I name that prism by its type of base. So remember, prisms have two bases that are parallel and identical to each other. So where are those two parallel identical shapes? Well, they are these triangles here. So this is a triangular prism. Okay, that would be its name. First name, last name. Triangular prism. Okay. How many faces, edges, and vertices does it have? You guys can pause, take a second and figure that out. All right, hopefully you came up with it. It has 5 faces. It has 2 triangles and 3 rectangles. How many edges does it have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, it has 9 edges. And how many vertices does it have? 1, 2, 3, 4, 5, 6. And this is one that's available on the websites that I showed you guys, so you could always check it out there too if that's easier for you. We are not going to worry about drawing the front side or top view, so don't worry about that. All right, let's take a look at another one. Name the figure. So remember, first name, last name. See if you guys could figure this one out on your own. Pause it for a sec. All right, first name, last name. Let's maybe start with the last name. Is this a prism or is this a pyramid? Well, I can see that there's a bunch of triangular faces all coming up to this one vertex here, this one point. So this is a pyramid. That's the last name. What's the first name? Well, the first name, I name a pyramid named off its base. So what kind of shape is this at the bottom here? That is a 1, 2, 3, 4, 5-sided shape. So that is a pentagon. Now we don't just say a pentagon pyramid. To the word pentagon, you're going to add the suffix al. Okay, so pentagonal. Same thing if you'd like hexagon, you just do hexagon al. And then when you pronounce it, becomes hexagonal. Octagon, add the al, becomes octagonal. So pentagonal pyramid. It's okay if you can't say it, as long as you can just spell it. Go ahead and figure out how many faces, edges, and vertices. So for faces, you should have come up with 6. There is 1 pentagon for the base, and then 5 triangles for the lateral faces. Edges, what do you think? Hopefully you came up with 10. There's 5 edges for that pentagon on the bottom, and then if you count for the triangles going along the side, there's 1, 2, 3, 4, another 5. So 5 and 5 is 10. And then vertices, 1, 2, 3, 4, 5, and then 6 up here at the top. Okay, so 6 vertices. Again, we're not going to worry about front, side, or top view, so don't worry about that. And I think, yeah, that is where we're going to stop for today. So hopefully you guys understood. Play along with those websites. I think that will help you guys out as well. And then tomorrow we'll have some practice problems for you.